Hello, here's a tricky application one that's going to involve a quadratic equation that we can solve with a quadratic formula. Um, so let's see. We've got that the owners of a daycare center or a preschool or something like that plan to enclose two adjacent play areas against the back wall of their building. Um, They have 300 feet of picket fence, and they would like the total area of the playground to be 6,000 square feet. Can they enclose the playground with the fence they have? And if so, what should the dimensions be? So with something like this, it always helps to draw a picture to make sure you understand what's going on. So let's say that this is the building here, and they're going to try to build two adjacent play areas against the back of it over here. Whoops. So something like one here and with a divider between these two things. So it's going to look something like that. And the picket fence is all of this dotted line stuff I have. That's like the total perimeter, sort of, except the perimeter doesn't need to include the wall because you already have a wall there, so it would be silly to build a fence right against your wall. Uh, so, uh, so let's see if we can make variables for the things that we don't know. Maybe we could say that x is the width, this dimension. And that should be measured in feet, if everything in the problem is about feet. And if that's x, this is going to be x here too as well, because it's going to be a rectangle. That's how rectangles work. And let's see. We know the total the total of all of the fence has to be 300 feet of picket fence. So what is the length of this side over here going to be in terms of x? Well, 300 makes up x plus x plus x plus whatever's missing here. So I think this is going to be 300 minus 3x. And so then we want the total area to be 6,000 square feet. So the area of a rectangle is its length times its width. And in this case, we want that to become 6,000, and that's going to be equal to this length on this side, 300 minus 3x times x. And so that gives you a quadratic equation we can try to solve now. So I'll distribute the x into this. So you get 300 times x minus 3x squared. And then we can subtract the 6,000 from both sides. And let's just write this in the standard form, 0 on one side. And I'm just going to write the negative 3x squared first. And then plus the 300x. So I can just have it in the standard form, like so. And I noticed that these are all divisible by 3. So I can just make all the numbers smaller and nicer by just dividing everything by 3 on both sides. 0 divided by 3 is just 0. Negative 3x squared over 3 gives you negative x squared. 300x over 3 becomes 100x. Negative 6,000 over 3 becomes negative 2,000. And this one now, we can solve this with a quadratic formula, which will look like this. So I'm using a equals -1, the b is 100, c is -2000, and so that should become -b is -100 plus or minus 100 squared minus 4 times a times c divided by 2 times a. There. And we're going to plug this into a calculator. Remember, we need parentheses around the whole top of the fraction and around the bottom of the fraction. It's going to be -100 plus, and we'll have to do the minus on another line, the square root of 100 squared minus 4 times -1 times -2000. And press the right arrow to get out of that square root. Close that parentheses, so those parentheses are wrapped around the whole top of the fraction. Divide that by 2 times -1, like so, with that in parentheses, and press enter, and that gives you that result. And then we could press second entry to just go back into that and change that minus over here to, or change the plus to a minus, like so. So you get those two solutions. These are the solutions of the equations, approximately, but it's not really answering the question. We want to see what the dimensions should be to make it so this all works, so that we can actually build this playground. So if x is 27.64, then the length on the long side is going to be 300 minus 3 times that. And we can do that on a calculator. We get 217.08. And if x is 72.36, then if we figure out the length is based on that, by plugging that number in here, 72.36, we'll get 82.92. So these are two different ways you could get an area of 6,000 square feet. We're either going to have a pretty a small width and then a really long length, which would make a playground that looks like this, or this other way, if x is pretty big, the length will be a bit smaller. Both of these layouts should give you your 6,000 square feet for the area inside the playground. Now, you should actually answer the question, write out a sentence, include units, and that sounds like a good answer for this one. By the way, I'll mention that I actually made a mistake in the video for when I was making this video, and I had to go back and start over. I accidentally wrote a positive 2,000 here and got all the way through to the end and then realized the answer didn't make sense. But it's okay because I was paying attention to stuff. I realized what the problem was and I went back and fixed it, and now I know to be careful with that thing. So mistakes with this happen to everybody, and the more practice you get, the fewer of them you'll make, but you might still make a lot of mistakes. So just keep checking your answers, check them in the back of the book, check them with your friends, all that stuff. Okay, I'll see you in class, but you'll see me in the next video.